Hey. All right, so it's a bad hair day, no makeup, but I did get new glasses, so I wanted to show you my new glasses. Aren't they cool? They look like my old glasses. Yeah. All right, so let's continue on reviewing for Unit 2 FRQs. This one's my favorite one because it brings in the DOFS, right? The best dance move for 2019-2020, the DOFS. All right, so we've got ourselves a scatter plot here. This is attendance per game for 30 baseball teams in 2017. Also shown is the least squares regression line and the computer output. Now, remember, for the AP exam, they said they are not going to create questions that require the use of the T.I. Joe. Wow, I can't believe that. So you're not going to have to worry about going to step around, edit, and going through and doing all that stuff. Instead, they're going to be providing the computer output, they're going to be providing those scatter plots, and you, my friends, just have to analyze it. All right, so we got this, we got this. All right, so let's see, let's jump in. Let's jump in. Interpret the slope of the least squares regression line in context. Ooh, it was nice, they warned you. All right, so the slope, when you look at the output, they have constant and then they have wins. If you recall, constant is the y-intercept, right? The equation y equals mx plus b is how you did it in the algebra days. But in AP Stats, we switched it up and we said that it's a plus bx, right? We flip-flopped it around. Anywho, the slope is attached to a variable, it's changing, whereas a is a constant. So that's why they use the word constant for that y-intercept. Okay, so anywho, we're looking for the slope. So we don't want 10834, we want the next row. All right, so this next row is talking about slope. Even though it only says wins, be careful. Slope is rise over run. Slope compares both the x and the y-axis. So why don't they list both of those? I don't know, maybe just to confuse you, whatever. All right, so what they're saying here is wins is on the x-axis. All right, so wins is the input in this equation, right? Wins goes in and then the output is attendance per game on the y scale. All right, so the coefficient that's attached to x, right, attached to wins is 235. So to get your first point for this section, you had to correctly identify 235. All right, the next 2 points come from your context, right? Making sure you have it written the right way. I like to do a little bit of legwork before I write my sentence. Remember, slope is rise over run. You always put it over 1. Y to the sky over x. So I look at my picture to help clarify. The y-axis is attendance, and the x-axis is number of wins. Now I'm ready to write my sentence. So for every 1 win, right, it's not 235 wins. That's why this chart's confusing. It's for every 1 win, attendance increases by 235. So here's my sentence. For every 1 win, the predicted, right, y-hat, attendance per game increased by 235 people. All right, so you had to have the 1 to 235 in the right context of wins to people, right? Wins to people. So to get an E, you had to do all 3 of those things. If you didn't do one of those things, then you're at a P. And if you didn't do all 3, ruh-roh, then you get an I. On the positive end of things, if you used, for example, the let's see, what is it, 10,834, if you use that as the slope, but you wrote the right sentence somehow, then you could still get partial credit. All right? Okay. So on to B. Explain why it is not reasonable to use the least squares regression model to predict attendance per game for 0 wins. All right, well, check it out. Number of wins, our scatter plot doesn't go anywhere near 0, right? 60 to 70 is where the data starts. So if you're making predictions where you don't have predictions, that's called extrapolation. My document camera just froze. Hold on, let me see if I can figure this out. All right, so on your EPI grading scale, they're looking for 3 things to happen in your sentence. The number of wins in the data set only includes values 60 to 100, right? Look at that range, 60 to 100. Making the prediction for 0 wins an example of extrapolation. Name drop! Extrapolation is not reliable, or maybe you could say it's not reasonable for making predictions. So those are the 3 things. They wanted you to talk about where the data is collected and how using 0 is an example of extrapolation, and extrapolation is not reliable, right? Because we had to say why it's not reasonable. All right, so if you're able to do those 3 things, it's an E. If you only did 2 of those things, it's a P. And if you missed all 3, that's an I. All right, for this one, what is the value of the correlation coefficient? You gotta know your vocab. Correlation coefficient is R. All right, so in the printout, they give you R squared. R squared, by the way, that's called the coefficient of determination. Coefficient of determination. All right, R squared determines the percent that can be explained. So we can explain 12.29%. Remember, we don't talk about our X's. We can explain 12.29% of the attendance. All right, that's not a whole lot with this model when you think about it. Okay, anywho, correlation coefficient is the R. So we got to take this percentage and we got to get rid of the square. You get rid of a square by square root nothing. So square root nothing, and you get 0.351. To get a full E, you had to have R. You had to show square rooting. And of course, you had to have the right answer. Partial credit if perhaps you square rooted 12.29 instead of 0.1229. And incomplete if you were just totally off the charts wrong. All right, notice you didn't have to have any conclusions. It just wanted to know what is, right? It didn't ask you to explain anything, but just for fun, for practice, we can explain that this is 0.351, and correlation, if you recall, goes on that scale of -1 to 1, 0 in the middle. 0.35, that's pretty weak. All right, so if you had to go a little farther on the free response for your exam, you might say something like weak positive linear correlation. All right, so that would be the strength of this model. All right, onward. D-Dog, if the point representing 64 wins and attendance of 40,786 people per game is removed, what's going to happen to the slope? And what's going to happen to the correlation coefficient? Remember, correlation coefficient is the R, right? It's not R squared. R squared is the coefficient of determination. Anywho, let's find where this point is. 64, 40,000. Okay, so this is the one they're talking about. So if we get rid of this point, I did my best just to eyeball it. If there's no point up here, then this black line doesn't have to be pulled up that far. All right, with that point gone, there's nothing pulling it in that direction. So it's going to flatten down here a little bit more. All right, so redrawing it in, I'm not saying this is what it would be. This is just my estimate looking at the pattern. Looks like my slope is now steeper. All right, that slope is getting steeper. So to answer this first question, if the point is removed, the slope would be greater or steeper. This removed point is to the left and above the least squares regression line. And with this point gone, there are no values in this area that would pull that least squared regression line up to the left. All right, so to get your full pointage here, you had to talk about how the slope would be greater and why. All right, so you want to describe what's happening in the graph. All right, cool. The next one is correlation coefficient. If the point is removed, the correlation coefficient would be greater. It's going to be stronger or closer to 1. So I put all these different ways you might have worded it. You don't have to say all, right? Pick your favorite. This removed point is outside the linear pattern of the other points, right? Again, this removed point is outside the linear pattern of the other points. So if we get rid of it, that's going to make your scatter plot more strong, right? It's going to strengthen it. Okay, so notice 1, 2, 3, 4 things for D here. To get an E, you had to point out all 4 things. All right, partial credit, you only did 2 or 3 of those things, and incomplete if you weren't able to get there. All right, take a look at your scoring, and E is where the point. P is half a point, and I is 0 points. There are no half scores on this though, so if you ended up with a 3.5, you would have to look at it holistically. Would you round up to a 4 or round down to a 3? Hopefully you'd round up to a 4 because you were able to sprinkle in context. You're very clear. You showed all your work. You went above and beyond. All right, so that's about it on DOFS.